other classes. Okay guys, welcome to our first review for UCLA. Okay, this stuff will be discussed this coming Saturday, February 1st at UCLA. So I'll just take this as an advanced review. So please feel free to ask questions, guys. And then Cleo, would you mind read the problem for me, please?
If the sculpture is an ice sculpture in the form of a sphere melts in such a way that it maintains its spherical shape, the volume of the sphere is decreasing at a constant rate of pi, right?
Yeah.
Cubic meters per hour. At what rate in square meter per hour is the surface area of the sphere decreasing at the moment when the radius is 5 meters?
Okay, thank you, Cleo. So we're gonna have volume. So the first thing that we're gonna highlight is volume. And what is next? Surface area. Okay? Surface area of sphere. So again, we are going to recall formulas right here. The one that you learn in geometry. Okay? So first is volume. So what is the formula for volume, guys? Aside from that, for the sphere, volume of the sphere.
Higher square.
Pi r square.
Volume, no. Pi r cube.
You already forgot, right?
Pi r
So we have for volume of the sphere. Volume of sphere is gonna be 4 over 3 pi r cube. That is the formula for the volume of a sphere. And then how about surface area of sphere? Surface area, I just write here S. S means surface area 4 pi r square. So these are the two important formulas. So guys, starting tonight, we're gonna review all those formulas in geometry. The sphere, the circle, whatever. Okay, a cube. So first, we're gonna have constant. The volume has a constant rate of 2 pi cubic meters per hour. That means, what can you say about this? This is not the rate of the volume, right? Okay. And then, at what rate in square meters per hour is the surface area of the sphere decreasing at the moment when the radius, so the radius is 5 meters. So, these are the important thing that we're gonna focus in here. First, we have volume. So since we have volume, we're gonna take the derivative of the formula for the volume. So we say now dV dt. Okay, so dV dt is equal to, so we say 4 over 3 pi times, take now the derivative of r cube. What is the derivative of r cube? 3r squared. So times 3r squared. Now, what you notice right here, what cancels out? Can we cancel out 3? Okay. Anyway, if you multiply 4 times 3, that gives you 12. And then over 3. So, why not make use of cancellation right here? We cancel out 3. Therefore, dV dt is equal to 4 pi r squared. Okay. before we continue, question, clarification. But I have the intention why I did not write correctly. Is there something you notice that I miss? I have the intention because we are taking the derivative. So, is there any error in here? I have the intention. I wrote it that way.
Hold that query.
What does it say? What do you mean by that, Danny? What is lacking? Okay. So, I'm just tricking you guys. This would be dr dt, the rate of the radius. Okay, dr dt. So, we have now 4 pi r squared dr dt, right? The rate. So dr dt. Okay. So, and then we are solving in terms of the rate of the radius, right? So, we are solving in terms of the rate of the radius. So, we're gonna solve dr dt. Okay. So, if we do dr dt, what we do with 4 pi r squared, we're gonna divide that both sides, right? So therefore, can I just write it here? 4 pi r squared dr dt is equal to dv dt. So, solving for dr dt is now equal to dv dt over 4 pi r squared. Okay. But is dv dt given? What is dv dt? It is the rate of the volume, right? Is the rate of the volume given? What is that rate of the volume? What is the rate of the volume given? Say it. 2 pi. Very good. So, the rate of the volume given as 2 pi. So, you're gonna plug in 2 pi over 4 pi, and then is the radius given. What is the radius?
Medium.
5. So we say r, which is 5, and then square. Okay? Simplifying this further, can I just have dr dt here? Dr dt is now equal to, this is 25 times 4, 100, right? Then on top is 2. Can you reduce that into lowest term? 1 over 50. Okay, so we say, or I'll just write first 2 pi over 100 pi. Then reduce this. This is gonna be, the pi cancels out, right? So pi cancels out. We cancel out pi, and then 2 divided by 100. So 1 over 50. So this is now the dr dt. So 1 over 50. Okay. Can you box this temporarily? Just box this temporarily. That this is the rate of the radius, 1 over 50. Next, we now do the surface area. So, surface area, we say 4 pi r squared. So, we have ds dt is equal to 4 pi and then times 2r dr dt, right? 2r dr dt. Okay, so we have ds dt is equal to, this gives us 8 pi, and then who is the radius given? What is the radius? The radius is 5. And have we identified the rate of the radius? What is the rate of the radius?
1 over 50.
1 over 50. So 1 over 50. Okay. So this means ds dt is equal to, we're gonna have 40 pi over 50. 40 pi over 50. Can we reduce this now by 10? 40 divided by 10. 4. Then pi. 50 divided by 10. 5. So this is now our final answer. So what letter is 4 pi over 5? So it's gonna be letter A. Okay? So this is the answer. Letter A. Where's Mike?
I don't know. Here, top right, it's closer. Right at. Right the bunch.
So let's move on to the next problem. Problem says the position of a particle moving along a straight line at any time t given by s of t is equal to t squared plus 4t plus 4. And then the question is, what is
No, baby, don't
the acceleration of the particle when t equals 4? So what is this, guys, in the context of the problem, the s and t? So s of t is the, can you recall what we learned last time? Plus 4t plus 4. This is what kind of function is st? S of t. This is position function. So this is position function.
Shall we read? Shall we read? Right, shall we read?
Okay, so it's asking on acceleration, but can we jump right away to acceleration without passing velocity? We cannot. That means take the first derivative of the position function, which is s prime of t, which is equivalent to velocity, right? Okay, so we say s prime of t is just equal to the velocity, okay, vt. So take the derivative of the position function. Derivative of t square is 2t, okay, and then derivative of 4t is 4. So this is not the velocity or the s prime of t. So velocity, next to velocity would be acceleration. So we do s double prime. S double prime of t is just equivalent to acceleration, okay? And acceleration is the v prime of t, right? The velocity of t, the v prime of t, and then this is equal to a of t, which is acceleration. So take the derivative of the velocity, that means 2t plus 4 velocity, and then acceleration is 2. The derivative of 2t is 2. Therefore, this is the acceleration. So what letter is acceleration? It's gonna be letter A. Okay, any question on this problem? Reglanta, guys. Remember, this is now an actual review. And this will be discussed this Saturday, UCLA, AP Readiness. So I'm just giving you in advance. Okay? That's how I care for you guys. Okay, can you copy?
I just didn't turn that light on.
So, next problem, guys. We do next problem. We have table right here. Time from 2 to 8. And then this is velocity. And then acceleration. V prime is acceleration, right? V prime of t is acceleration. Okay. Now, a particle travels along a straight line with velocity vt. The table above gives selected values of vt and its first derivative v prime of t, at which of the given values of t is the speed of the particle is increasing. So, I need you to highlight this, speed of the particle increasing. Now, remember, this is velocity,
Go get this
and the v prime is acceleration. Now, when can we say that the speed is increasing? Can you recall? Say it loud, Chris.
Same sign.
Same sign. It's increasing. How about if the signs are different from each other?
Decreasing.
It's decreasing. So always remember that. When the question says increasing, the speed is increasing. So you have to look into the table. Now, another way or another way of recalling that one should be the acceleration. So I need you to do that or memorize that. Velocity and acceleration have the same sign. Okay? Have the same sign. So increasing means velocity and acceleration. So velocity and acceleration have the same sign. Okay, so from the table, at what time is the acceleration and velocity have the same sign? Give me one, starting left.
Ow, ow.
What time does acceleration and velocity have the same time? Okay, so the first is at time 2. Okay, they are both negative. The velocity is -5 and the acceleration is -3. So this is the speed is increasing. What else? 8. Okay, they're both positive. So therefore, what is our option? A, B, which is 4 and 6 only. C, which is 4 and 8. or T, which is 2 and 8 only? What letter? Diego, what letter? Hmm? Huh? 8?
D. I said D. D for
Okay.
Diego.
So, I have the intention I call your name Diego because it starts with letter D.
Double D.
It is a clue.
So you know.
Question, please. Okay, so next problem. A particle moves along the x-axis so that at time t is greater than or equal to 0, its position is given by, so this is the position function, guys. X of t is equal to negative 5t squared. Question, what is the particle's average velocity? So I need to double underscore this. Average velocity on the time interval from 0 to 3. So that's the interval. So we have the function xt, position function, is equal to negative 5t squared. Now we have average velocity. So average velocity.
That's 6.4. Or 6.3, Mike.
No, the correct, the mastery check.
I don't know. Diego's.
Now we have given interval from 0 to 3. Therefore we say f of b minus f of a, right? But since the given position function is x of t, so therefore we say f of 3 minus f of 0
Zero.
over 3 minus 0, right? So always remember or recall f of b minus f of a over b minus a. So we say now average velocity, so we say x of 3 minus x of 0 over 3 minus 0. Can you follow? Okay, which means we say now x of 3. So what is that? Negative 5 and then 3 squared. Am I right, guys? Okay, so this is now the x of 3 and then minus the x of 0. So we say negative 5 times 0 squared. Anyway, I have the intention to write this. Okay? Over 3. But what is this? It's gonna be nada, right? 0. So can I just cross this out? So what you have right here, 3 square is 9 times 5. So then negative, so we have negative 45 over 3. So what is our final answer? Negative 15. So what letter is negative 15? Letter C, right? So this is our answer, letter C. And a question, guys. Reading. Okay. So we have problem number 10. The graph over the interval from 0 to 8. Okay? The time is from 0 to 8. A particle moves along the x-axis and the graph of the particle's velocity is shown below or shown above. On which of the following time interval is the particle speed decreasing? So particle speed is decreasing. Okay, when can we say that the particle speed is decreasing? This has something to do with a previous problem that we have. when the sign is different, meaning the sign of the velocity and acceleration is different.
2 to 4,
Okay.
2 to 4, 6 to 8.
So let us take a look on here.
I got it.
Now, from 0 to 2, from 0 to 2, what is the velocity? Is the velocity above the x-axis or below? Below, that means negative. Okay? How about the acceleration? Look at the acceleration, guys. Is the acceleration positive or negative?
Negative.
So these are both negative. That means from the interval 0 to 2, the speed is increasing. Right? Okay. But the question is, we need to look at the particle speed decreasing. That means the velocity and acceleration signs are opposite. Now look at the interval from 2 to 4. So interval from 2 to 4. What is the velocity? The velocity is
Negative.
below. That means if it is below the x-axis, the velocity is negative. How about the acceleration? Is the acceleration going up or down?
Up.
It's up. So it's gonna be positive. So therefore, is this decreasing speed or increasing speed? Decreasing. Why? The signs are different, right? Okay. Next, let's do interval from 4 to 6. From 4 to 6. What about the velocity? Is the velocity up or down? Is it located up or down? Up. It's above the x-axis, so it's gonna be positive right here, right? How about the acceleration? Up also, so both are positive. So these are both positive, while this one are both negative. Then next, we have interval from 6 to 8. So look at this. What is the velocity? Velocity is positive. How about the acceleration?
Negative.
Negative. Okay. So that means this signs right here are different. So this speed is decreasing. Decreasing in what, on what particular interval? From 2 to 4 and also from 6 to 8. So you have a union, right? From 2 to 4 and then 6 to 8. So the best option is letter D. Letter D is the right answer.